algebraic expressions. Polynomials. Polynomials, degree of polynomial, relationship between zeros and coefficient of a polynomial, coefficient form and index form of the polynomial, synthetic division. We have studied expressions and equations in our previous class, are also known as polynomials. The polynomial in variable x is called as p of x. 2x squared minus 5x plus 3 is a polynomial in variable x. Now look at the polynomial. The terms are arranged according to the descending order of power of x. This is the standard form of writing any polynomial. Now, degree of polynomial. The highest power of variable in the polynomial is called as the degree of that polynomial. The polynomial p cubed minus 7p squared plus 10 have a degree 3. Or we can say that the polynomial p cubed minus 7p squared plus 10 is a polynomial of degree 3 because in this polynomial, the highest power of variable p is 3. And the degree of this polynomial, 3x plus 5, is 1. Let us put x is equal to minus 1 in the polynomial x squared minus 3x minus 4. Therefore, p into bracket minus 1 is equal to minus 1 squared minus 3x into bracket minus 1 minus 4. And hence, we get p into bracket minus 1 is equal to 0. Hence, at x is equal to minus 1, we get p into bracket minus 1 is equal to 0. Similarly, at x is equal to 4, we get p of 4 is equal to 0. Since p of x is equal to 0 and x is equal to minus 1 and x is equal to 4, minus 1 and 4 are called the zeros of the polynomial x squared minus 3x minus 4. From the examples above, we can see that in any polynomial p of x for any real number k, if p of k is 0, then k is called 0 of polynomial. Now, relationship between zeros and coefficient of a polynomial. Let us find the relationship between zeros and the coefficient of different types of polynomials. Let us take a linear polynomial. P of x is equal to 2x plus 3. Suppose for x is equal to k, p of k becomes 0. It means 2k plus 3 is equal to 0. Therefore, k will be 0 of the polynomial. From the equation, we can get value of k is equal to minus 3 by 2, where 3 is the constant term of polynomial and 2 is the coefficient of x. In general, for a linear polynomial ax plus b, if k is a 0, then p of k will also be 0 and then value of k will be minus b upon a. That is, 0 of polynomial is equal to negative of constant term upon coefficient of x. Let us take now a quadratic equation. 2x squared minus 8x plus 6. We have learned how to factorize quadratic polynomials by splitting the middle term. So here we split the middle term, that is minus 8x, in such a way that sum of two terms will be minus 8x and whose product will be first term 2x squared into constant term 6, that is 12x squared. Therefore, 2x squared minus 8x plus 6 is equal to 2x squared minus 6x minus 2x plus 6. Take 2x common from 2x square and 6x and 2 from minus 2x and 6. Again we can take x minus 3 common. And lastly, we get the factors 2 into bracket x minus 1 into another bracket x minus 3. Now value of p of x will be 0 if x minus 1 or x minus 3 will be 0. That is, x is equal to 1 or x is equal to 3. Therefore, 1 and 3 are zeros of polynomial 2x square minus 8x plus 6. Now, if we add both zeros, we get some 4. 4 can be written as minus of minus 8 upon 2. We can see that minus 8 is a coefficient of x and 2 is a coefficient of x square. Therefore, sum of zeros is negative coefficient of x upon 2 is coefficient of x square. If we multiply both zeros, we get product 3. Now 3 can be written as 6 upon 2. That is, 6 is constant term upon 2 is coefficient of x square. In general, if alpha and beta are zeros of polynomial ax square plus bx plus c, then sum of zeros, that is alpha plus beta, is equal to minus b upon a. And product of zeros, that is alpha into beta, is equal to c upon a. Let us consider a cubic polynomial. P of x is equal to 2x cube minus 5x square minus 14x plus 8. 4 minus 2, 1 by 2 are the at most 3 zeros of this polynomial because for these values we get p of x is equal to 0 if we check. We can write 5 by 2 as minus of minus 5 by 2. We can see that minus 5 is the coefficient of x square and 2 is the coefficient of x cube. Therefore, we can write sum of zeros is equal to negative coefficient of x square upon coefficient of x cube. And if we multiply these zeros, we get the product minus 8 upon 2. 8 is a constant term and 2 is a coefficient of x cube. Therefore, we can write product of zeros is equal to negative constant term upon coefficient of x cube. In cubic polynomial, there is one more relation here. Consider the sum of the products of the zeros taken 2 at a time. We have 4 into bracket minus 2 plus minus 2 into 1 by 2 plus 1 by 2 into 4. And the result of sum of the product we get is minus 14 by 2. Now minus 14 is coefficient of x and 2 is coefficient of x cube. In general, it can be proved that if alpha, beta and gamma are the zeros of the cubic polynomial ax cube plus bx square plus cx plus d, then alpha plus beta plus gamma is equal to minus b upon a. Alpha, beta, gamma is equal to minus d upon a and alpha, beta plus beta, gamma plus gamma, alpha is equal to c upon a. Coefficient form and index form of polynomial. Let 4x square plus 7x raised to power 5 plus 2 minus 5x cube be a polynomial. Now writing given polynomial in descending order is called standard form. Therefore, 7x raised to power 5 minus 5x cube plus 4x square plus 2 is a standard form of 4x square plus 7x raised to power 5 plus 2 minus 5x cube. Now there are some missing terms of x raised to power 4 and x. We can write these terms in expression with coefficient 0. This form is called as index form of polynomial. Therefore, 7x raised to power 5 plus 0x raised to power 4 minus 5x cube plus 4x square plus 0x plus 2 is an index form of 4x square plus 7x raised to power 5 plus 2 minus 5x cube. And writing coefficients of each term in a round bracket separated by comma is called as coefficient form of polynomial. Therefore, 7, 0, minus 5, 4, 0, 2 is the coefficient form of 4x square plus 7x raised to power 5 plus 2 minus 5x cube. Synthetic division. Divide 3x cube minus 8x square plus x plus 7 by x minus 2. Now in synthetic division, we arrange the coefficients of dividend as shown. Now divisor is x minus 2. Hence we write 2 here. 3 is the first coefficient. Take 3 down and multiply 2 with it. Write product 6 below second coefficient, that is below minus 8, and add sum of minus 8 and 6, that is minus 2. Now multiply 2 with minus 2 and write the product minus 4 below third coefficient, that is below 1. The sum of 1 and minus 4 is minus 3. Now multiply 2 with minus 3 and write product minus 6 below fourth coefficient, that is below 7. The sum of 7 and minus 6 is 1. This last number in the box is remainder, and remaining numbers 3, minus 2 and minus 3 to the left side of remainder are coefficients of the quotient polynomial. Therefore, the quotient polynomial will be 3x square minus 2x minus 3 and remainder is 1. We can write dividend is equal to divisor into quotient plus remainder. Summary. In this subtopic, we have learned polynomials, degree of polynomial, relationship between zeros and coefficient of a polynomial, coefficient form and index form of the polynomial, and synthetic division. So that is all in this lesson, student. Maths is fun, so keep learning. Bye.